Hi everyone, welcome back to the another video of Engineers Academy. So guys, over here in this particular video we are going to learn about the different types of the suspension geometries over here. That is nothing but the camber, caster, toe in, toe out, and kingpin inclination and steering axis inclination. So guys, over here in this particular video we are going to learn these 4 parameters. So guys, if you're new to my education channel over here Engineers Academy, please consider subscribing because your subscription will really motivates me to make more of such educational videos. So guys, please watch my video till the end, and guys please do subscribe to my educational channel. So let's begin with our today's topic of the different types of the suspension geometries over here and the steering fundamentals. So guys, let's begin with our today's topic. So now let's talk about the camber. So first of all, if we see an automobile from the front side, from the front view, okay, let's say this front wheels, like the front wheels are mounted on an axle in such a way that these front wheels make an contact with the road such that these front wheels are having an axis that is of, we can call it as a wheel axis. Now the road is also there, the axis or a perpendicular is drawn to the road, that is called as the normal axis. So when this particular wheel axis makes an angle with the normal axis, this particular angle can be called as the camber angle. So this particular camber angle is nothing but the angle between this axis of the wheel and perpendicular drawn to the road, that is of the normal axis and the wheel axis. So these are the two important parameters over here while deciding the camber. So there are 3 types of the camber: the positive camber, negative camber and zero camber. So when these particular wheels are tilted outwards, okay, from the top side, as you can see over here, then in this condition the angle which is made between these two wheel axis and the normal axis, then it is called as the positive camber condition. And in the opposite case, like this particular wheel gets tilted from the top side, that is this particular wheel gets tilted inside from the top side, then this particular condition is called as the negative camber. So the angle made over here in this condition between this wheel axis and the normal is called as the negative camber. And in certain cases the axis of the wheel is completely aligned to the normal axis. So over here in this case the camber angle is 0, so it is called as the zero camber. So these are the 3 conditions in the camber. Now this particular camber angle decides like the stability of the vehicle. So normally it is like the positive camber is recommended in all the vehicles. This particular positive camber like is there, and due to that like positive camber while taking turns, while cornering, or like it will reduce the scrub which is there at the bottom side of the wheel, like it will be help in the improving the life of the wheels while taking the turns. So this particular camber angle is basically for the wheels and to maintain the stability of the vehicle. So moving ahead, next is nothing but the caster angle. So now if we look at the vehicle from the side view, from the side, so now let's talk about the front wheels basically. So this particular front wheels are having the steering arrangement is provided. So it is the angle between the steering axis and the normal axis of the wheel. So this particular angle can be called as the caster angle. So this particular angle which is there at the steering axis and the normal axis of the wheel can be called as the caster angle. So now this particular steering axis is tilted towards the rear side, it will make a positive caster angle, and if this particular steering axis is on the normal, then it is called as the zero caster. And when this particular steering axis is on the tilted towards the front side, front wheels, then it is called as the negative caster angle. So normally this positive caster is always recommended and it is always used in an automobile system because this will maintain the stability and it will help to maintain the straight axis steering and promotes the steering wheel self-centering. So moving ahead, next is nothing but the toe in and toe out. Now over here, if we look at the vehicle from the top side, if we look at the front wheels, that is the axle, if we notice that these two wheels are not perfectly straight, it will move, like it will tilted at the front side or else at the rear side. So there is a slightly tilt over here. So this particular tilt can be called as the toe in or toe out condition. Now let me explain this particular toe in and toe out the condition to you. Now at this particular case scenario, this front wheels, okay, these two wheels are shifted in such a way that the distance between the two wheels of that particular axle, if that particular distance is less from the front side and more from the rear side, then that condition can be called as the toe in condition. And the same over here, if the distance between these two wheels is more from the front side and less from the back side, as you can see over here in this particular image, so this condition can be called as the toe out condition. Now these are the conditions which are provided to increase the stability and to give a good comfort while riding. So that is the ultimate objective of this toe in and toe out, to improve the stability of the vehicle while cornering, while braking, while doing acceleration. So this is the reason the toe in and toe out are provided. Basically the toe in is recommended for all the vehicles. Now let's talk about the steering axis inclination and kingpin inclination. Now guys, we all know about this steering axis. So while taking a turn, this wheel is rotate at a certain axis, and that particular axis can be called as the steering axis. Now this axis is completely vertical. So let's imagine the front view of that particular steering axis. Now over here, this is the steering axis is present for both the wheels, and the axis of that particular wheel is also there. The distance between the axis of the wheel and the steering axis is called as the scrub radius. Now if that particular steering axis is completely vertical and the axis of the wheel is completely vertical, now in that case the scrub radius will be more, and while taking a turns, driver has to imply more efforts. So to reduce that efforts, this particular steering axis is slightly inclined in such a way that the scrub radius will be less. So the lesser will be the scrub radius, the lesser will be the efforts of the driver while steering the wheel. So this is the reason the steering axis is slightly inclined to the axis of the wheel, and this particular angle which gets formed over here is called as the kingpin inclination or else the steering axis inclination. So this particular kingpin inclination helps us to reduce the efforts while steering and to increase the stability of the vehicle. Also over here, the another important parameter is nothing but the camber of the wheel. The positive camber helps to improve the distance between this. It means the negative camber will reduce the scrub radius, and the reduction in the scrub radius will improve the stability and the steering geometry over here. So this is nothing but the kingpin inclination and steering axis inclination. So guys, this is all about the steering fundamentals that we have seen so far in this particular video. So if you're having any doubts, any queries, please leave a comment. If you like my video, please hit like. That will really motivates me to make more of such educational videos. And guys, please do subscribe to my educational channel, Engineers Academy. Thank you so much guys for watching this video.